Okay, again, it's another exam, and I know it seems like a lot of things to be asking students, but the bottom line is you take them one piece at a time. Again, I hope you're catching on at this point. You should work these problems before watching the videos or looking at the answer key. Everyone gets stuck. I get stuck. I do like to have answer keys, by the way. I'm going to look at the problem set, and I'm looking for low-hanging fruit again. I'm going to say 1 looks pretty easy to me, and I'm also going to say 5 looks easy. All right. Now, if I thought about other problems that might look easy to me, I'm going to say the triangle problems look like they might be easy, particularly if you had trigonometry. This one over here looks a little tricky to me, though, but I want to do one at a time. All right. So I'm going to read it to you, and as I read these things, again, neatness kind of counts, but I'm just kind of working through the problems. I'm going to practice. All right. But it says a number x. I'll write this down. A number x is, I'm just reading it left to right, is 2 more, right? The number x is 2 more than the product. I know they're talking about product now. That means there's going to be 2 factors at least. It says the number x is 2 more than the product of its reciprocal. Well, its reciprocal, they're talking about the number, is 1 over x, and its additive inverse. What's its additive inverse? Minus x. So I wrote down what they said. Now my problem is, can I figure out what the x is? Because they want me to determine the number. What I would do here is multiply both sides by the LCD, which is x. You would get x squared equals minus x plus 2x. All right? So again, I wrote down what they said, and now I'm making some attempt to solve it. You get x squared. Make sure I did that right. Multiplied by x, right? X, multiplied by x, you get minus x. Yeah, x squared equals minus x. And let's put this down. X squared plus x equals 0. I'd probably factor that, right? X plus 1 equals 0. So x could be 0. And what's the other one it could be? X could be minus 1. I got to be honest with you. One's pretty obviously wrong, by the way. I'll tell you why. I can't take the reciprocal of this one over here. So I'm going to say this is my answer. What's the number? Minus 1. Now, here's the problem. We did it quickly. If you made a mistake, at least you made a mistake quickly. You might have misread it. You might have done the algebra wrong, whatever. All right? Remember, they're looking for give you credit. Let's take a look at our answer key, and let's see what we come up with over here. And I think I made a mistake somewhere. Let's take a look at it. Oh, no, I didn't. X equals 1. Did I write that over here? I'm sorry, I made a mistake. I just see it now. I looked at my key, I made a mistake. And I want to tell you what my mistake is. It's really egregious. I did this, and I said this. This is simply not true. All right, it is simply not true. So I'm going to go back and say, I got to be more careful now, right? So I'm going to erase my work and say, man, I made a mistake. I made a mistake. So what's minus x plus 2x? It's not minus x, it's plus x. I apologize. Let me go back and solve it. What do you get? X squared minus x equals 0. And then I get x minus 1 equals 0. X would equal 0. This is zero product rule. Or x would equal 1. I know it can't be this because that has no reciprocal. And this is the answer. So again, the answer key is correct. All right, I'm going to look at this. I'm going to skip 2. I'm going to skip 3. I'm going to skip 4. And I'm going to go right to 5. All right? I know it looks tough, but the bottom line is I'm looking at it, and I'm starting to think maybe I could just simply look at this and figure it out. I don't think it's going to happen quickly, though. But I'm looking at this, and I want to get this in the problem. Right? And how would I do that? I probably would square both sides. Now, by the way, this could be wishful thinking. Maybe that's not going to help. Then I have to try something else. But if you square the left side, let me write this down for you. And you square the right. Well, the right's easy. It's 25. The left side, when you square it, looks like this over here. And that equals 25. And again, this could give you a dead end, but it's a short dead end. What do you get? X squared. Then you'd get 1 plus 1, provided x isn't 0, by the way, plus 1 over x squared. And now it would equal 25. And then I'm getting x squared plus 1 over x squared would equal, well, 1 plus 1 is 2. This would equal 23. All right? Now, is that what I wanted to do? Sort of. All right, I got this. I know what this is. And what is it? It's just 23. So I'm going to write this down. 23. All right? Let me look back over my work again. Yeah, be really careful about this. I got the x squared. And let's see, 1 plus 1 is 2, 23. Yeah, I think I did okay. So 23 minus 7. But I got to cube it. All right? Again, mistakes happen. If I make a mistake, I'll know it by looking at the key. But on a competitive exam, you don't know if you made a mistake or not. Right? So 23 minus 7 is going to be 16. Let me just check. Yep, 16 and 7 is 23. And I got troubles here. Do I want to do the arithmetic? Now, I'll be honest with you, if I was on the competitive exam, I don't think I really would do the arithmetic. Because I'll be honest with you, it's just too simple. But it's time consuming. So I'm going to write this a little bit differently. I'm going to write it as 2 to the 4 times to the third power. And what's that going to be? Well, it's going to be 2 to the 12th. All right. So maybe you know your powers of twos. 2 to the 10 is 1024. Is that 1024? Let me see. 2 times 2 is 4, 8, 16, 32, 64, 128, 256, 512. Yeah, 1024. Now 2 to the 11th, I multiply by 2 now. That's going to be 2048. And 2 to the 12th, we'll check our key later, is going to be 4096. Okay, let's look at the key, see how we did. We're looking at problem number 5 now. Whoops, I went too far. Yeah, right there. All right, we did okay. All right, so what I'm going to do now is I'm going to cut to the chase, and we're going to start doing problem number 2 now. Now, my goal over here is to look at number 2. I'm going to read to you they got a triangle with sides A, B, and C, and they give me this relationship over here. They want me to find the angle C. All right? So what I want to do is, this looks like it might be related to the law of cosines. It looks like that, right? So I'm going to write this down, law of cosines. So C squared is equal to A squared plus B squared minus 2AB cosine of angle C. All right? I use a different letter for uppercase. The uppercase letter C looks like this, where the lowercase letter looks like this over here. I hope you can differentiate. All right? Some people have really good penmanship, and it's really differentiation. Their letters is quite easy. Other people don't. I don't have very good penmanship, by the way. So I'm looking at this thing. I'm wondering, can I use what I've been given to find out what the angle C is? And I'm kind of looking at it, and I'm wondering, what would I do given this information over here? And one thing I would probably do is just simply clear the fraction. And let me write this down for you. And what would you get? Let's see. You'd get A cubed plus B cubed plus C cubed, and I'm multiplying both sides by A plus B plus C. So you get C squared times A plus B plus C. Now, by the way, that may not help me at all, but I'm kind of still looking at it, and let me just keep going with this. And, well, you know what? I'm seeing something now. I'm seeing A cubed plus B cubed plus C cubed is equal to C squared times A plus B plus C cubed. So now I'm seeing that A cubed plus B cubed, right, I'm taking C cubed from both sides, by the way, is equal to C squared times A plus B. All right? I'm seeing that. And then what do I notice? I notice, from a really basic algebra course, I could probably factor that pretty quickly. And what would that factor to? A plus B times, this is a difference, sum of perfect cubes. It would be A squared, let's see, minus AB plus B squared is equal to C squared A plus B. I'm going to divide both sides by A plus B now, and I get something pretty simple. I get A squared minus AB plus B squared is equal to C squared. Now, granted, this may not help me, but I do know something now. And I want to tell you what I know now. I know this, and I wanted it. And let's write this down now. So what are you going to get over here? A squared minus AB plus B squared, which is C squared, is equal to A squared plus B squared minus 2AC cosine of the big angle C. Well, I'm going to subtract A squared from both sides, and I'm going to subtract B squared from both sides. And what do you get? Minus AB equals minus 2AC cosine of the angle C. Again, you may forget why you're doing this. You're doing this because you want to find the angle C. What I'm going to do now is divide both sides by minus 2AC. I'm going to write that down, by the way. Minus 2. I'm sorry, I made a mistake over here. This is B. Let me make sure I didn't make that mistake up here. I'm sorry, I made the mistake up here too. All right, let me just see if I made a mistake anywhere else. No, I corrected the mistake. So minus 2AB. By the way, it's important you know these things are going to work out, so you'd expect that. So what do you get over here? 1/2 equals the cosine of the angle C. So now I hope you realize the angle C has to be between 0 and 180. Question is, where's the cosine equal 1/2? Well, it's going to be between 0 and 90, by the way, for this over here. Let's put that down. So when does C equal 1/2? And I hope you realize it's a very simple reference triangle. That'd be 1, 2, root 3, 60 degrees. All right. Now certainly you can also write the radian measure down for that, and that would be pi over 3. All right. Not bad. We're getting the same answer. And again, they put the work down for you as well. We just worked through it. All right. So I'm going to say the problems we've done. 1 wasn't bad. I did make a mistake on it. 2 wasn't bad because I realized that it's something to do with law of cosines. 3 looks like a killer to me. I'll go through that. I'm going to go to 4 now. So 4 says there's a triangle ABC with A equals 3, B equals 8, and C equals 10. Prove that the measure of C is 3 times the measure of B. Well, you know what? I'm going to do the law of cosines again. And let me write this down for you. I guess what I'd do, since we're talking about the angle C, I'd write down C squared is equal to A squared plus B squared minus 2AB cosine of angle C. Now, let me see if I can do that. And what's C squared? That's 100. Right? I'm just, because I talk about angle C and angle B, and we'll go through this one step at a time. Let's see, A squared is 9. Right? I'm just looking at this, and B squared is 64. Minus, let's see, 2AB. That's going to be 2 times 3 is 6. Well, 48. Cosine C. And this is going to be 100. 9 and 64 is 73. Minus 48. Cosine C. Well, I got to do some work here, don't I? That's going to be 27. Yep, minus 48. Cosine C. And I'm getting this now. And what do you get over here? You get minus 27 over 48 is cosine of C. And I got to figure this out now. And so what is it going to be? Maybe it's easy, maybe not. Cosine of C. I can divide by 9. So minus, oh no, I'm sorry, not 9. I can't do that because 48 is not a 9. But I can do by 3. So minus 9/16. By the way, I hope you know that C, just looking at that number, is between 90 degrees and 180 degrees. All right, hope you know that. All right. And if I do it a reference triangle in that, what do I mean by reference triangle? What's that going to be? This would be 9 and 16. All right, 9 and 16. So let's take a look at the other one. And so I wonder what the other one is. The other one is, it says, prove that the measure of C is 3 times the measure of B. All right. So I know what C is. But then the question is, can I show that this thing over here is this thing over here? Well, you know what? It's a multi-angle formula, but I'm going to kind of write it down for you and steps 2, because I don't want to memorize too much. But this is the cosine of C, which I know the number, by the way. I'm just going to write this down. It's easier for me to write this down over here. This would be the cosine of 2B plus B. I'm going to write this down in steps for you. This would be cosine, let's see, 2b times cosine b minus sine 2b times sine of b. All right? And this is a little bit tough now, isn't it? See, you say, am I taking the wrong road? Well, you could be, but if the road's too difficult to travel, I'd say don't take that road, but this doesn't look that bad. And I'm going to start to write this down. I'm going to write down cosine of b, and now I'm going to use a double angle formula for this one and a double angle for this one over here. All right? Minus sine b. And the double angle formula for sine 2b is pretty simple. It's 2 sine b cosine b. And again, this could be a dead end. I'm looking at the cosine of 2b, though, and I don't know. I guess I should put it in terms of, maybe in terms of cosines. Put this over here. So 2 cosine squared b minus 1. All right. Let's take a look at this. Cosine b, 2 cosine b, that's squared minus 1, minus 2 sine squared b cosine b. Well, I'm going to factor it, and I think I'm seeing something. So I'm seeing cosine b, and I'll factor that out. And what would you get? 2 cosine squared b minus 1 minus 2. Let me see if I'm doing that right. Yeah, minus 2 sine squared b. Let's see what we get over there. I think I want to get everything in terms of cosines now. And what do you get there? You get 2 cosine squared b minus 1 minus 2 something, right? That's going to be 2 times 1 minus cosine squared b. Boy, this looks like it might be a dead end, right? So what do you get over there? 2 cosine squared plus 2 cosine squares, which is 4. Right, I just did these two over here. Minus 1 minus 2 is minus 3, right? Well, this is crazy. All right, so what do I got over here? And I think I have something. And what do I have? Yeah, look back over here. I guess I have to compute cosine of b. All right? By the way, the reason I say that, I'm trying to show that this thing here, right, I'm trying to show a relationship between the two. And I got to do it. So do I know what cosine c is? I think we did that before, minus 9/16, right? But I didn't compute the cosine of b, by the way. All right, let me make sure I read this correctly. Prove the measure c is 3 times the measure of b. I think we're close. I just got to get b. Now, I'm going to cut to the chase, by the way. It's really taking too long over here. But I also would need to do this here. I didn't realize that. I did that. I did this one. It's really the same thing. So it's 3/4. Let's write that down. All right, I'll do very carefully over here. So minus 9/16, 3/4 times 4 times 3/4 squared minus 3. And let's see if this works out. Minus 9/16, 3/4. What would you get over here? You would get 9/4 minus 12/4. I'm just doing the arithmetic. Minus 9/16, 3/4. And then what do you give there? It's a quarter. And 9 minus 12 is minus 3. Yeah, you get it, minus 9/16. So it worked out pretty good. So again, I didn't compute this for you, but it's really the same thing as computing this thing over here. It's pretty simple to do that. And then writing down a relationship. And again, someone says, well, I remember these things over here. That's fine. But the bottom line is, I guess I didn't need to do all that work. If I knew what B was, I could have probably just did it here. It would have been pretty easy to do. But, it's pretty easy just to get it in terms of cosines too, and we did that. All right, let's see what we've done so far. We've done 5, pretty easy. A little tedious for 4, but we got through it. We did not do number 3 yet, but we did number 2 and we did number 1. So I'm going to go to number 3. And I got to be honest with you, a lot of times people miss, some of the solutions to the problem over here. But let me read it to you. What does it say over here? It says that this has to be equal to 1. So I'm going to say one really simple solution to this problem over here, and we'll check it, by the way, is if this thing were equal to 0. All right? I want to point out where that case is. It's really the simplest case. Now, how do you do that? You take the power, which is x squared minus 10x plus 21, and factor it, and you would get 3 or 7. Now, if you're very retentive, you can do this if you want. For example, you can check 3. And what do you notice about that? The exponent would be 0. And over here, I hope you realize if you plug in 3 here, that this would be a non-zero number here, right? What do you get? You get 9 plus 15 plus 5. And that's it's an easy number to compute, but it's certainly that raised to the 0 power is 1. And you probably should check x equals 7. A little more difficult to do, by the way, but the power would be 0. And what do you get on the inside? You would get 49 plus 35 plus 5, and that also equals 1. So I'm going to say I found 2 solutions over here, right? Now someone says, I wonder what the other solutions would be to the problem. It's when the inside, this guy over here, becomes the number 1. So that's also not a bad thing to do. And so you write this down over here, and I'll go through the checking of it. You kind of solve it, and you get 2 more answers. You get these 2 answers over here. And most students are able to do that, by the way. So I would be checking these numbers out over here. And one number I check out 1, and the other number check out was minus 4, right? And so I'm going to say over here, checking them out, what does that mean? You plug it in here, and in both cases you get 1. You get 1 in both cases, by the way, whether you choose 1 or minus 4, and you raise it to a power. Now, it really doesn't matter what the power is. I don't care what the power is. Any power here is going to produce a 1. So this is what most students are able to do. They're able to get those 4 solutions here. They're very simple, by the way. What do they say? The base has got to be 1. The power could be anything. The power could be anything. The other thing they say is, there could be any non-zero finite number here, and then it's raised to a power 0. That's also fairly easy to do, all right? Where they get screwed up, though, and this is a problem, is in the case that they're not considering. And I got to be honest with you, it's a much more difficult problem, by the way. And this is the case that eludes most students. And what is it going to be? It's where the base is minus 1. And that's the case. What's over here is this must be an even power. So what do you have to do? You have to solve the base from minus 1, and you get a solution to that, and there'd be 2 solutions over here. These would be the 2 solutions. I'm not saying they both work, but both produce a base of minus 1. Both produce a base of minus 1. What's the power, though? And this is where students get really screwed up. Let me do the minus 2 first. Now, minus 2 is being plugged in here. What would you get? 4 plus 20 plus 21. What kind of number is that? That would be an odd number, all right? So if I tried the minus 2, I'd get an odd number here. This doesn't work. Let's try the minus 3. I'm going to plug it in. Maybe that doesn't work either. So what'd you get? 9 plus, I'm trying minus 3, right? 30 plus 21. What does that give you? Well, that gives you 39, 40, 60. That's an even number. So what's it going to give you? That's going to give you plus 1. All right? So I found another solution. So let's list all the solutions that we have. And I'll list them down for you. We found 3. We found 7. They're up here. We found minus 4 and minus 1. And we just found minus 3. They're the 4 solutions. What's their question, though? Find the sum of all the solutions to the problem. Let's write this down. The sum of all solutions to the problem is going to be, well, let's write this down. 3 minus 3 is 0. Minus 4 minus 1 is minus 5 plus 7. It's 2. The answer is 2. All right, so we finished it up. Tough. Some of the questions are extremely difficult. I'm not saying they weren't, but we got through that. Again, if you think I'm making any errors and you need to reach out to me, please do so. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right? As long as I'm not overwhelmed, I'll respond to you, okay? If I get overwhelmed, though, I don't think these videos will ever become popular, by the way, but if they do, by chance, and in getting thousands of emails, I'll certainly have to deal with that, probably put them into spam folders or something. But again, it's only a few people asking questions. I can answer them, all right? Thank you so much for paying attention.